So very good evening. So today we will be learning something about the measurement of central tendency. So I have slide presentation with me. I'm sharing the slide presentation with you, which actually tells about the measurement of central tendency. So here we go. So measurement of central tendency is actually the law of averages. You can say it is in the other way we can call it as a law of averages. So there are flaws rather than while we are studying the laws of averages. So these measures of central tendency cannot be used interchangeably. Just see the story of this particular person who happens to be a statistician, and he actually measured the depth of the river by taking, and the average depth of the river was found to be 3 feet, and then he said that I am 6 feet, so I will be able to cross this river. But what happens is in front of you that while crossing the river, he actually drowned himself because at one place the depth of the river was more than his height, but at the other places it was only 1.5 feet deep. So he actually lost his life while going with it. So that's why that there is a use of central tendency and it should be used wisely. So the mean average of the value, what is the mean? Mean is the average of the values. When we are talking about mean, we have to add all the values and divide by the number. Median is the middle value. You can say the middlemost value of the series which we are having. And for that we have to either arrange the series from small to large or large to small as shown over here, and then we identify the middle value. Mode is the frequency, how many times a thing is occurring in a particular series is called mode. And there are use of these central tendencies are used at various places in various ways. So measurement is also to be done around the variability, and measurement of variability around the mean is called variance. And the sum is squared of deviation from the mean is which is divided by n minus 1, and we get the variance. Variance actually tells that to what extent the distribution is deviated from its mean, or what is the deviation of the distribution from the mean, or how wide it is being it is told by variance itself. Standard deviation is also there, which is actually a positive square root of the variance for the distribution as such, and in this case we have just now arrived at various measures of variance and standard deviations. So so measurement of deviation from normality, for this purpose we use kurtosis. Kurtosis is the measure of peakedness or the flattedness of a series. Kurtosis value is near to 0, which indicates the shape is shape is close to the normal. A positive value of kurtosis indicates a distribution of more peaked than the normal one, and whereas the negative value of the kurtosis indicates the shape which is flatter. So if we see this in the figure over here, so the things which is a negative one, it is called platecrotic, and leptocrotic is the positive skewness, and mesocrotic which is termed as a normal skewness, which is near to normal. So kurtosis value will be given by as if it is there means you can say the kurtosis value will be between +1 and +1 and -1, which is considered to be the excellent one, but the value is between +2 and +2 and -2 is in many cases also acceptable depending on a particular application, you can say. So skewness measures to what extent the distribution of the values deviate from the summary. So here comes the skewness, that if it is a negatively skewed, it will be having a longer tail towards the negative side, or you can say towards the 0. And if the tail is on the other side, then it will be called a positive skewness. So even the skewness and kurtosis both play a very important role when we are talking of a normal distribution. So for the distribution like 3, 5, 7, 5, 6, 8, this is and the maximum value is 9 and the minimum value is in the range is given. So these are also one of the things by which we actually go for the measure of the size of the distribution. So measurement of stability is done by the standard error. Now, what is a standard error and why it is called a standard error as such? So standard error is, you can say, the SPSS computes it for the mean and the kurtosis and the skewness, and as indicated above, the standard error is designed to be the measure of the stability of the sampling error. So to what extent the sampling error is stable? So if a random sample is taken from a population, the mean can be computed as a single number. Now, if another sample is taken from the same population, the mean will definitely come to be a different one. So standard error is the error between the means of the means. So when this is small, the sample is more reliable, or you can say it is having a greater stability. So how to just calculate it? You have to go to on analyze, then you have to go to descriptive statistics, and then you have to click on descriptives. So while you will be clicking on descriptive, this window will appear. So the variables whose descriptive have to be calculated can be selected. For example, over here, we have to calculate the section. So section will come over here, and then we will go to options. When you go to options, this particular dialog box will be open where we have to calculate the mean or other things whatsoever we need to calculate. We have to check the checkbox, and then further we have to just see whether the output we need in the order of variable list or the alphabetical or what, and then we will press the continue, and then we will get the result. So the result will be displayed on your computer screen as you have done it yourself. You have to do it by your own hands with the hands-on exercise, and there is further exercise which you have to do while you will be doing this workshop. So this is the exercise which you can do on the data set which has been provided to you. With the help of this, I hope you will be able to understand the calculation of this descriptive statistics in a much better way. Thank you.